anyone, because first decoder is labeled as 1 and second decoder is labeled as 2. So Y0 to Y3 is your output, input is your A and B, and enable is G dash. So now what you can see, when your enable input is high, enable will be enabled only when it is 0. Why? Because it is active low. So when your enable input is high, it will not enable your decoder to work, and it will not depend upon A and B. So it is both are don't care, and all the output Y0 to Y3 will be high. High means nothing. Why high means nothing? Because it is a active low output. For active low output, selecting it or decoding it means by making it a 0. So if it is 0, that means that specific output is enabled or active. So when you have enable input as high, your both A and B are don't care, and all the output are high, means your decoder is not in a working mode. When your enable is LLL means 0000, that time your decoder is in a working mode, and a 0 and 0. 00 will make Y0 to be selected. Y0 to be selected means Y0 should be a 0. Here 0 is written as L, and rest all will be written as high. That means 1, because it is a active low output. Same way L and H means 0 and 1. 0 and 1 means 1. So that is why Y1 is selected. 1 and 0 for the second last row, 1 and 0 means 2. That is why Y2 is selected. And last one, H and H here is 1, 1 means 3. That is why Y3 is selected by making it low. So this is a truth table for any of the 2:4 decoder here. So it is taking care of your active low output and active high input and active low enable. So all this is clear. I hope this is clear. We had discussed it before also, so it should be clear to you people. Okay. Next, you may get in your exam about the internal logic diagram or internal circuit of 74LS139. So internal circuit is shown here. You can see this circuit. In this circuit, what you can see is you are having 2 NOT gate. Okay, now you have to understand it very carefully. Listen to me very carefully. Number one, I think you people can just look into one of the decoder, that is one of the 2:4 decoder. So you just look into it for only this much. Only this much. So on your screen now is only one 2:4 decoder, the first one, 1A, 1B, and all 1 Y0 to Y3 here. Now you have to understand this diagram very carefully, because this is the internal diagram of 2:4 decoder of 74LS139. So what you can see here is 1G dash is your enable input, and because it is active low, your bubble is kept this side just to indicate that this is a active low input. This is the indication of active low input, and that is why it is made in this form with a bubble to left hand side. Okay, so this is a buffer which shows active low input enable. Okay, now coming on to your all these things. Yesterday you had made a simple 2:4 decoder, and you made AND gate at the output layer, right? Yesterday you made in the class, and you were seeing a AND gate at the output. But here NAND gate is there. Why NAND gate is there? Can anybody answer? Instead of AND, why NAND is here?
It's an active low output.
Correct. Because it is an active low output. That is why in place of AND, I have a NAND. So all the output will be low whenever that specific thing is decoded or activated. So NAND gate is used. So now what you can see, to make a 0, 0, to make a 0, 0, I want A bar and B bar. So see how it is connected. It is connected to A bar and a B bar. Okay, and when what you can see here is you have A bar and B bar here, where my mouse is showing, it is A bar here and a B bar here. To get A, they don't take it from here. They make one more NOT gate, negate it again, and to complement means here you get a A. So when you want A and B here, the output is connected in what way? A is connected here. A double complement becomes A only. A gets connected here. B double complement makes it B here, and B gets connected. So you can see in this diagram, your A and B are being connected after this double complement. It's not directly being connected by this. This is their way of showing. Even if you don't make two NOT gate and make one NOT gate and show, that also is not a problem. But in your standard textbook, it is given like this, mostly because of the specific internal structure diagram. Okay, now you can also see that enable is connected to all. Yesterday we had seen in the basic 2:4 decoder that enable gets connected to all, and if your enable is a 0 here, then only it becomes a 1 here, and then only your NAND gates are activated and make your A and B working for the output. So this is your internal diagram of one of the dual 2:4 decoder of 74LS139. If you have any doubt in this, you can ask me. And you can see that the pin numbers are also written here. Pin number 1, 2, 3 and 4, 5, 6, 7. I hope you people know that in any IC you have a VCC and ground also, and that is why you will be able to see that 14 pin is not here. After this, we start with 14 pin is here. Specific pins are kept for ground and VCC. So the pin number what you can see here is 1, 2, 3, 4, 5, 6, 7. Same way here you can see 13, 14, 15 and 9, 10, 11, 12 here. Okay. So which pin number is missing? That pin number is for your, yeah, it is missing. So that is for your ground and VCC. So 8 is not there. So 8 is for that. So 9, 10, 11, 12, 13, 14 and 15 is here. So 8 is not there and 16 is not there. So 8 and 16. So what do you understand? It's a 16 pin IC. Okay. Always ICs are even number pin. I hope in your lab you would have seen this that any ICs are even pin, and mostly in one corner VCC will be there, other corner ground will be there. Anyway, we don't have to discuss on that. So this gives you internal diagram of your 74LS139, and all the part of 74LS139 is clear in this. Now next we will see 74138. Okay, and then we will go into details of using it for certain application. Now because you people know clearly your 7413 you will be able to appreciate 74LS138 also. What you can see in 74LS138, this is IEEE logic symbol. What you can see here now is 1, 2, 4 is used as your input. Again 74LS138 is a 3:8 decoder. You will have 3 inputs, which is active, high. Your input is active high and output is again active low. So input is active high, output is active low, and you can see that you have 0 to 7 as your 0 to 7. Why not to Y7 is your output, active low output. And now very, very important for you to understand here is it has 3 enable pins. It has 3 enable pins. Out of that, 2 enable pin, that is G2A dash and G2B dash is active low, and 1 enable pin that is called sometimes as master enable also. The master enable pin is active high. So you should remember this, that it consists of active low enable pins also and one active high. Now you may be thinking, what is the need of so many enable pins? The need of so many enable pins is that you will be able to see in a later stage that how your such enable pins help you to actually use it for various purposes. Okay, now I want you people to analyze it carefully, and as you have already done for your 2:4 decoder, you will be able to analyze the block, the internal diagram here. Okay, only I will make you understand this part, the enable part. Enable part, you can see that you have a specific diagram for your enable part. So what you can see, G2A dash and G2B dash, because it is active low enable, with a bubble it is being connected here. And G1 is active high, because G1 is active high, this complement is being negated here. Two bubbles are there, means complement is being negated, right? So you have a enable must, all the enable pins are being taken care here. So now you can see that all of it, so now imagine when G2A dash, G2B dash both are 0 0 and G1 is 1. So to make this encoder work, G1 should be 1 and G2A dash and G2B dash should be 0. So you analyze what is happening. 1 means you get a 1 here, and these are 0 0 means finally you get a 1 here. So what happens here? You get 1 1 1, and what is the output for NAND gate for 1 1 1? It's a 0, and then that makes your rest of the input, if it is a 1, your NAND gate output becomes 0, but if it is a 0, it allows your rest of the inputs to work upon it. So if your G1 is high, G2A dash and G2B dash are 0 0, that makes the condition for the encoder to work. If any one of it is not working in the way it should, then it will not be enabled only. Okay. Now I want you people to analyze this diagram, and if you have any doubt, you please ask me right now. I'm giving you 1 minute time. No doubt, everybody understood everything. So what you can see here, A dash, B dash, C dash will give you 0 0 0, and when this is 0 0 0, this will be activated, and why not dash will become 0, right? Why not dash will become 0. Okay, so because again this is active low output, sorry, that is why you have a NAND gate here. And as the previous diagram showed, that A is being used after 2 complement and A dash after 1 NOT gate. So that is how all the series of your NAND gate is connected. Is this clear? Is this clear? So now I want you to see the truth table of this. Okay, truth table of this. Now all of you should see the truth table of 3:8 decoder, that is 74LS138. So now what you can see is, if G1 is 0, what is G1? G1 is your master enable. G1 is your master enable. If it is 0, but G1 was active high. Active high means if it is 0, it is not enabling it. So if it is not enabling, rest everything becomes don't care. It does not allow it to work. Now, if your G1 is a don't care, means either 0 or 1, then what will happen? Then also all will be don't care, whether your G2A is high or not high, or G2B dash is high or not high, does not matter. Things will not work out. To make things work out, only one condition is there, that is G1 being a 1, G2A dash and G2B dash being a 0. So you can see actual working starts from this 4th row. Till 3rd row, it is showing you the operation of these enable only, where it shows that nothing will work out ABC will be don't care in all these conditions when your G2A dash, G2B dash is not 0 and G1 is not a 1. So till 3 rows, all the output will be high, high, high. That means it is not enabled, not in a decoding mode, not working as a decoder. But as soon as G1 becomes 1, G2A dash and G2B dash becomes 0, 0, means what? It is enabled. So it forms a normal decoder now. When A, B, C are 0, 0, 0 means Y naught is selected by making it 0. Same way if it is 101, 101 means what? 5. 101 means 5. So Y5 is selected by making that a 0. Same way 111 is 7. So Y7 is selected by making it 0. So this truth table, block diagram, internal circuit diagram, all these things should be very clear to you people to understand this and to use it for various other combinations. Is it clear to you? Any doubt in this? Any doubt in this truth table? You people need to copy this truth table, block diagram and everything in your notebook. Maybe in another 2 days time, I will create a place where you all will be uploading your module 2 notes with respect to these decoders. So you can't keep on saying that I have not finished it. You will have to finish it in time. Okay. So this is about your 74LS138 and 139 block diagram, truth table, working, operation. Okay. Now, any doubt is there with respect to this? Okay. Now, can you see on your screen? I had asked you a question that I want you to make a 3:8 decoder using 74LS139. So what was the question? Question was construct 3:8 decoder using 74LS139. If somebody has done, can let me know. Anybody could do it or not? Say yes or no. Only three students have done the homework also. I did not expect this performance from you people. Yes, did you understand 74LS138 and 139? Anybody is able to make it or not? Yesterday we have done something like this. It's not that difficult. What is the step 1? Step 1 is to short, as one of you asked also. To short 1A and 2A and 1B and 2B. That is shorted. So when I want 3
2B, ma'am.
huh?
We can start 2B, we
2B,
start
ma'am.
2A and 1B.
2A and 2B. Okay. Because of this, I will make it in a different color so that there is no doubt to anybody. So it is 2A, 1A and 2A is connected and 1B and 2B is connected. So whenever we are using a 3:8 decoder means you are supposed to give me a what do you say? You have to give me 3 input, maybe A, B, C, 3 input, and that is your 3 input, and you will have a 8 output that will range from Y0 to Y7 maybe, right? So 3 input and 8 output for a 3:8 decoder. So when I say 3 input, this are my LSBs. B and C are my LSBs. So what will be your LSB in this case? And when you have shorted, which one will be what? This one will be your B and this one will be your C. Now what about A? Where A will come from? A is your MSB. A is your MSB. So what you want when your A is 0, when your A is 0 and BC is ranging from 00 to 11, you want Y0 to Y3 to be activated. So what you want when A is 0, one of the 2:4 decoder will be activated. And you know that 74LS139 is
And
active
A
low.
input you give with a NOT gate to 1G dash, and without NOT input you give it to 2G dash.
Without NOT, you will give it to 2G dash.
Yes, ma'am, because A is 1, right?
Now, where did I tell that A is 1? A is 0 for half of the cases and A is 1 for half of the cases, no? And I want Y0 to Y3 as my first decoder output as my Y0 to Y3 here also. So I want my first decoder to work for Y0 to Y3, right? If I want my first decoder to work, I need to make my first decoder enabled. And to make it enable, what should be given to 1G dash?
A bar.
If you give A bar, see, I want A for these four cases 000 to 011. For these four cases, A is a 0, right? A is a 0. So if I connect directly A to this, what will happen?
Ma'am, with NOT gate, no, ma'am. 1 will be the input. So if we give NOT gate, it will come 0.
And does it change because it's active high or active low?
Yes, it changes. No, yesterday
And
you
so
have
basically over
done.
here A has the value 0 initially. And when you put a NOT gate, it becomes 1.
NOT gate, it will come 0.
No, Baba. See, let me complete it first. Okay. Now you see, imagine for this 000 to 011, A is a 0, right?
I'm not that, ma'am. The doubt I'm having is that what is the initial value of A? What does A have?
A has as per your truth table.
Not
A,
as per truth table, on the signal you're giving to the IC, what is
uh,
the value of A over there?
A is your input. No? It depends upon the user what you want to give A as. A is user's input.
Okay,
Okay.
okay. So, yes, ma'am. Got it, ma'am.
So A is a user input. So it is a 00001, then 10, then 011. Okay. And so in this case, A is user input, no? A, B, C, all are user input. So when I give a 000, what happens? A is a 0. A is a 0. It will go and enable my first decoder. A is a 0. So this NOT gate will make it a 1. And this 1 will go and disable my second decoder. Right? So when A is 0, it will enable my first decoder. And when B and C are 00, so this B and this C are 00. So 000 will give me Y0 to be active low output. Are you understanding? Same way, A0 and 11. So till A is equal to 0, for all the cases when A is equal to 0, your decoder 1 is being working. As soon as A becomes a 1, when in this last four cases, when A becomes a 1, this will stop enabling your first decoder, and A1 will make A bar as 0 here, and you get a 0 here, and your second decoder will start working, and you will start getting your Y5, Y6, Y4, Y5, Y6 and Y7 here. Are you getting? So this 2Y0 will behave as Y4, 2Y1 will behave as Y5, Y6 and Y7. Is this clear? Any doubt in this? Yes or no?
What, ma'am? Understood, ma'am.
Okay, so if it is clear, then quickly we will do some simple question with respect to your decoder. Okay, so in yesterday's class we had done certain questions, and we did up to question number 6. Question number 1 to 5 I did. Question number 6 out subtractor was your homework. Question number 7 is what I did now, and question number 8 is what we will do now. So question number 8 is, I want you to implement.
I'll copy this down.
Yes, tell me.
You copy this on 2 minutes.
Okay. Implement. I am giving the question. You people can carry on the copying, and then you can. All this I will be using this diagram only. So let us be clear that the diagram should be neat and clean. Yesterday I had made you copy something. I dictated you something that whenever it is an active low output, what gates are supposed to be used. I hope you people have written, and with that each one of you should be able to do this question. Once I have 3:2, and on this only I will be giving today's question also, so please understand it carefully. Okay, how will I implement this min term of 1 and 3? Implementing 1 and 3, do you want your cascaded decoder or not? Yes, answer me please. 1 and 3 will 1 and 3 does not require 3:8 decoder. So any one of this dual 2:4 decoder can be used. So question number 8A, I am showing with a, and which gate is to be used? Which gate is to be used? 1 and 3. I will call this one as F1, F2, F3. Okay. So 1 and 3. Which gate should be used here?
Or
NAND gate.
It will be active low output, means a NAND gate should be used. I told you yesterday, for active low output, NAND gate is used to implement the function. So this is your F1 function. Now, if you people are are not clear, I will explain you why we use a NAND gate. Okay. Okay. Now see, if I have a, I will use this area to explain you why do we use a NAND gate. See, NAND gate means what? If you have a X and a Y, this is NAND operation, right? This is a NAND operation, but in active low output, what happens? You have your outputs as a NOT, right? You can see, you have a bubble here, you have a bubble here. So you imagine your 1 by 1 is X and 1 by 3 is Y. But 1 by 1 and 1 by 3 is in a complemented form. So that is why I wrote it as X bar and Y bar. And what this NAND gate is doing? NAND gate is doing an AND operation and then a complement operation. So if I am getting like this, I am trying to say that 1 by 1 is a X and 1 by 3 is a Y. So it is coming in a complemented form. So what will happen? If I apply De Morgan's law, it becomes like this. And then what do you get? You get a X plus Y. So F1 is x plus y. So this is only how your min term should be connected. Yesterday you had used a OR gate, right? For a simple decoder, you used a OR gate. But when you have an active low output, you have to use a NAND gate to take care of this operation, that you get a min term implementation as per the given question. Is this clear? That why do we use NAND gate? Of course, you can always remember that you are using a NAND gate, but you people should understand why you are using a NAND gate. Is this clear? Now we will do our F2. F2 is what? 157. So whether this cascading is there or not, or this combination is there or not, F1 will work like this, because your B and C are connected to both 1A and 1B, 2A and 2B. Okay. Now for F2, what I want? I want 157. 157. So for 157, what is required? I need to get a 1. I need to get a 5. And I need to get a 7. And what gate should be connected here again?
NAND.
Again, it is a NAND gate, because again it is a min term. So this is the way of connecting, implementing a Boolean function for an active low output. Last, we have a max term implementation. Max term implementation, we wanted 2, 4, 6, 7, but it is a max term implementation. So what is the change now? Which gate should be used?
And
Yeah. Now you have to tell me why we have a AND gate. The way I explained for this one, if you can analyze and let me know, I will be very happy. Okay, I need 2, 4, 6, 7. So I need a 2. I need a 4. I need a 6. And I need a 7. 2, 4, 6, 7. And this should go into a AND gate. This will give me F3. Now quickly, you people should understand why we are using an AND gate. Now Y2, Y4, Y6 and Y7 is used, right? So let me show what is happening. Y2 dot Y4 dot Y6 dot Y7. And operation you are doing now. So I did AND. I did a AND. So F3 is a AND, but all these are in active low state. So it is in active low state. So it is all coming in this form. Y2 bar ANDed with Y4 bar, ANDed with Y6 bar, ANDed with Y7 bar as per the question. Right? Now again try to implement your De Morgan's law. So what does De Morgan law say? If you join the line, again you change the sign. So when you join the line and change the sign, you get a something like this. So what happens whenever your Y2, Y4, Y6, Y7 is it is active based upon your input. Y2 active means what? Y2 active means what? It should be your A should be a 0, B should be high, and C should be 0, right? 0, 1, 0. So 0, 1, 0 means what? Your Y2 will become high. Your Y2 will become high. Now, when Y2 becomes high, what will happen here? This Y2 is high and odd with rest, whatever rest be, but this 1 odd with rest of anything remains 1, and 1 bar will become 0. So F3 will become 0. So what does max term say? Max term say if any of 2, 4, 6, 7 comes, your F3 should give me a 0 output. I hope you remember your truth table of max term. Truth table of max term says that whenever this happens, whenever a 2 happen, a 4 happen, a 6 happen, or a 7 happen, my output should be 0. So what is happening? When a y2 happened, I had given you that example only, that a y2 happened, so f3 should be 0. So when a y2 is happening, your y2 is getting selected. Getting selected means what? Y2 is coming as a 0. Y2 bar is coming as a 0, right? Because output is in a complemented form. If you see here, what happens? You have a y2 is a 1, y2 bar is a 0. So when y2 is 1, 1 is odd with rest, whatever does not matter, because 1 odd with anything remains 1 and 1 bar becomes 0. So you get F3 as a 0. That is why we use a AND gate here. With this logic, you should remember forever that why did we apply a NAND gate for active low and a AND gate for a active low output for a max term. Is this clear to all of you?
Can you repeat why we used AND gate again?
See here, when we are using AND gate, I am showing you na F3 is ANDed operation of Y2, Y4, Y6, Y7. This is ANDed operation of your active low output. All I am showing is active low because I have to show this bar. So this is AND. After that, when I am applying this De Morgan's law, it is showing that all are odd together. All are odd together. But maxterm says that output should be a 0 whenever that specific function appears. So all are odd. Yesterday you remember we had used a NOR gate to get a 0. So here after ORing, I need to complement to get a 0. And how can we get this? We can get this by ANDing the active low output. When I do ANDing of active low output with the De Morgan's law, you get your answer like this. Okay. So this is how you can implement various Boolean expression using directly you can use 2:4 decoder, 3:8 decoder, or if the question says that implement this function using 74LS139, so you should remember that, okay, they are asking about 2:4 decoder, then you have to do this combination business. If they say that implement this question number 8B or 8C using a 74LS138, then what you will do? You will make a block diagram of your, okay, let us do this. Let us implement question number B using 74LS138. Okay, take that as your next question. Question number 9, implement 8B as 8B using 74LS138. Let us do it. Question number 9 is?
For the second, can you show the previous page? Huh?
Previous page.
Yeah, ma'am, done.
Done? Okay. Now, all of you write this question, that implement F2 of ABC, that is min term of 157 using 74. Okay. Implement F2 of ABC as min term of 157 using 74LS138. If you get such question, what you will do? You have to make your 74LS138. And how do you make that? You have to show your Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Right? This is your Y0, Y1, Y2 till Y7. This is your output, right? What is your input? Input are active high input. Active high input, right? So active high input, your input is like A, B, C, or here I have shown small a, B, C. You can use small a, B, C also, just because in the question I have shown like that. And how many enable inputs are there? You have a master enable G, and you have two inputs of active low type. And your active low input, what is the name of active low input? It is G2A dash, G2B dash. So what you have to do, how you will connect this G2A and G2. I have made the block diagram of 74LS138. Now we should show the connection. We should show the connection. So connection shows what? To enable my 74LS138, what should I do with G2A dash and G2B dash? I have to connect both of it to a ground, right? I have to give 0 to both of it so that it is allowing me to work. And to my G1, what should I give? I should give a logic high. If I give a logic high to G master enable active high input, and G2A dash and G2B dash, I should give 0. Then it will, this combination makes my 74LS138 in a working condition. Next, what I am supposed to do? Next, I should take this 1, 5 and 7, and what gate I should put? Again, I am supposed to put a Nand gate because active low output. Is this clear? Is this clear? What extra we did is, we just took 74LS138 and we made it in a working mode by making G as high and G2A dash and G2B dash as low. Is this clear? Can you quickly...
Mom, why are you making it low, mom, and the other one?
I had explained you, na, G is a active high enable input and G2A dash and G2B dash are active low enable input. So active low enable input means you should give a 0 to it to enable this IC, and active high means you should enable this as 1 to make it as a...
Okay, mom.
All these three are your enable inputs. Okay, so this is okay, good. So in the truth table I had shown you, na, 100 is the condition when the decoder works. Okay, so this is how you implement. Now I want you to quickly implement F3 also. F3 of question number 8C. It was 8C only, na? Yeah, 8C. I want you to implement 8C. What was 8C? 2467 max term. 2467 max term. So 2467 max term, how it will be? Your 2 will come out, your 4 will come out, your 6 will come out, and your 7 will come out, right? 2, 4, 6, 7 will come out, and it will go to one AND gate, and you will get your F3. Clear, no? Is this clear?